Okay, our next presentation will be given by Paul Rogers. Paul holds a BS and an MS in geography from Utah State University and University of Wisconsin-Madison, respectively, and a doctorate from Utah State University in ecology. Paul's prime area of study has been human impacts on vegetation in the western United States. He is an adjunct faculty member in the Department of Wildland Resources here, a USU Ecology Center associate, and the director of the Western Aspen Alliance. So please join me in welcoming Paul Rogers.
If you see skid marks on the front of my head, it's because I'm in this awkward stage of flipping the glasses off and on, but I'm going to attempt with the glasses on this time. I want to thank the previous speakers, particularly Simon and Dominic, just invaluable work on root systems coming out of Canada over the last couple of decades, and then the multi and complex interactions of disturbance from Dominic and his work, and also the comments of Greg. The bad thing is that they stole most of my punchlines, so I'll try to move through it anyways. But I'll come at it from a little different angle. I'm going to be talking about a proposal for a system of aspen typing across western North America. And I call it the many faces of quaking aspen, and you'll soon see why, and hopefully you'll pick up the biogeographic meanings in there. I probably won't bring up that word again. So here's where I'm headed. I want to talk about this idea of functional types, ecological functional types, and then specifically gauge that discussion towards disturbance. There are a lot of other elements in how we distinguish between those functional types, but for the purpose of this talk, we're going to zero in a little bit more on disturbance. And then things that can offset us, these confounding factors, mostly human-induced, from a resilient system. And I'll get into my definition of resilience near the end. That'll be a different way to approach it. But I think most of these definitions of resilience complement each other as opposed to conflict with each other. And then I'm going to give a couple scenarios which are going to overlap quite a bit with some of the things Dominic said, but I'll try to put a little bit different face on it. I also want to mention that the reason why you're hearing so much about aspen at this conference is because it's the chief hardwood throughout the Rocky Mountain and boreal systems, and it adds a lot of biodiversity, so it's a very important species. But also, this came out of a springboard workshop in which we produced this special issue of Forest Ecology and Management. But the idea was to first meet as a group and kind of have a think tank type environment, and then put those talks into this larger context of restoring the West. So that's why you're going to hear several parts to the Aspen show in this conference. So first of all, why functional types? This is an old-time definition, but an oft-quoted author, Baker, from the early 20th century, not the Fred Baker that was here recently at Utah State University, but this idea that we're always on this successional trajectory. And soon, if you haven't seen already, you'll see that that's not really true. And this is sort of the ultimate version of succession here. We have a little subalpine fir seedling growing in the base of a live aspen tree in the Bear River Range, right adjacent to where we're having the conference there. And so I'm going to suggest a real need for course correction. And the ideas I'm presenting are really a compendium of the literature. They're not new, but I would say they're new in terms of implementation in the management realm. And that's really where our target audience is. So maybe some need for course correction. Over time, I believe there's been a successional bias, basically putting everything into this category that Baker talked about a long time ago. There's also been a historical timber bias. There were areas where aspen was actually plowed over with bulldozers and eliminated so we could get more timber into systems, for example, in the Black Hills in South Dakota. And often inappropriate applications, and that's really what I want to target here. So the idea, if everything is successional, that all we need to do is clear fell it, we'll get a lot of coppice, and everything will keep coming back aspen, and that's the way it goes. Well, what if things aren't always the same type? Or what if they're similar types, but they're in very different geographic, climatic environments? So, and then this is just a philosophical change over time that I think we're all aware of, but I thought I'd paint sort of paint that picture anyways. The idea of a shift from command and control in the early 20th century in many fields of natural resource management to one of more adaptive management. So a definition here, functional types. Like dominant communities that differ markedly in their physical and biological processes. And some of the benefits as I see them, there's just an ecological awareness, so that we're thinking more about how these systems develop ecologically over time. And everybody knows that when we talk about functional types, we talk about our ecosystems, composition, function, and process. And I'm going to place more emphasis on the later two here. But also the application, I believe, is a little more intuitive. I kind of cut my teeth in natural resource management with these types of documents, habitat typing, vegetative typing, plant community types, and they have some real value, particularly at local scales, but they take a considerable time investment to learn them and to understand which plants are key plants to identify these different types. And they may be changing over time, as we've already heard in some of the previous talks. So I would suggest that some ecological process is a little bit more intuitive, and a lot of people have already done a lot of the work, natural resource managers, to understand their local ecosystems. And then towards resilience, and I like to use this natural range of variation concept. I'm going to come back to resilience later. I know the term is somewhat problematic, but however, it's in the title of our conference here, so if I didn't have it in here, I'd be remiss. So I'm looking at a really big picture here, pretty much the western half of this continent, and then I need to make clear here, when I'm talking about aspen functional types, I'm talking about areas where aspen can become the forest type. And by SAF definition, that's greater than 50% cover. So we need to be clear on that. There are large areas where aspen is present, but is often or most often not dominant in the north and in the eastern part of the continent. So I'm talking about those types of areas over time or currently that they're 50% cover. And then I think the message will become clear that one size doesn't fit all. Again, Dominic alluded to this, but I'm going to dive deeper into those waters here and sort of make some explanations of these different types. But I think this is our overall message with this work, is that if we're treating everything with the same formula, we're going to make some really bad decisions, particularly in a very rapidly changing climate as we move forward. So this is the framework. It's outlined in this work here. I have copies of those papers, and those will be available out on the table out there. But basically, we've come up with this framework for sort of management applications of Populus tremuloides. So quickly, we divide into a stable and cirral type, and I've got some photos up there. But stable would be complex vertical structure remaining almost entirely or entirely in a single species in the overstory, versus the sort of traditional cirral successional kind of wave there. But then we have these subtypes here, and this is at a very broad scale, and it is very much a framework, sort of something that we can start hanging our management hat on and probably refine over time in more local situations. So very broad scale. But there are a number of these pure or stable or persistent. I wouldn't quibble over the terminology so much as understanding what's going on there in a very different ecological function, therefore should be treated very differently in terms of management. And I'll just lay those out quickly and point out that there's riparian systems that can go either way. These are two very, very broad cirral systems in the continental U.S. I'm sure there'll be more as we move forward with this. Just to drive that message home, same type of photos here, but so what are the basic differences here? So we have one to several conifer species, shade intolerance, all the stuff that you learned either last year or 30 or 40 years ago, depending on your age. But I want to emphasize this, it's sort of contingent on a species dynamic, a species interaction, as opposed to a structural dynamic. So it's not so important, the phase and interaction of the species over time in a successional model, but in more of a gap phase, single tree, small gap replacement, structural complexity, that's going to be our real driver in these systems. And I'm talking about resilient systems. We're going to see examples of systems that have been thrown off course there in aspen. And then just to give these some sort of photo and our criteria for evaluation, it should be clear that this is a qualitative evaluation based on an extensive literature review. Over 100 studies are involved in this. And basically, we have all these criteria that we distinguish these by, and the next slide will kind of show you where we found significant differences. Some areas, basically because we know very little, Simon sort of alluded to this, very little difference between types, regeneration type, vegetative or seeding. We can't, at this early stage, say there's definite differences in that, but I evaluated differences, or we evaluated differences just within the cereal and just within the stable, and not across that boundary. So we found a number of qualitative differences, but where this talk is headed is really toward the disturbance realm here, because that's the theme of our conference. Just a quick run through all of these types and give you some idea of how they differ over time and space. And I've put their sort of major and minor associates up here to give you some idea of what species they're growing with, and that already gives us an indication that they're behaving different in different locations. Fire and harvest are probably the main disturbance agents. We don't have a lot of difference in topography, so size of these stands and disturbances are very large. They're most commonly stand replacing when they happen, and over moderate to long time scales. Contrast that with the montane forest type. Covers a broad area, very dissected over major mountain ranges, so you have a lot more species involved, both major and minor. But fire here, but insects and disease, and I always treat those as a complex, and I don't want to get into the weeds too much with the pathologists or entomologists, but they seem to act in tandem, and Worrell's work backs that up. But a little smaller in size just because the stands are smaller relative to the boreal type. Intensity is varying quite a bit, and fairly long frequencies, and it really is contingent, as Dominic pointed out, on the buildup of conifers in that system. I need to point directly to Doug Shinneman's work. It's a great loss that he's not here to talk about fire ecology in aspen, but I'm a co-author on that, as is Dominic and Bill Baker, but we go into much more detail, particularly in this system and a couple others, of how there are different fire ecologies for different aspen types, and that's important to know. So again, one size doesn't fit all. The Canadian parklands are mostly Canadian, also a little bit in Montana and Minnesota. We have these vast flat areas of mostly pure aspen. This photo is the only good one I could find, but it's not that great because a lot of this is human changed for agricultural purposes over the last century or so. But some different factors going on there, major agents. The size of disturbances, again, they're sort of dissected because of human intrusions. Stand replacing, mixed, and gap phase, a whole gamut of things. And then whenever you have drought, these things can be happening at a lower periodicity over time. Elevation aspect limited. Again, I refer to the fire ecology work. I see those papers were all gobbled up outside already. I'll try to bring more tomorrow. But no dominant agent, disturbance agent, but this adjacent conifer fires spreading into these so-called asbestos forests sometimes have some impact, and with the right situations can actually burn through them depending on the size of those stands. And then wide variation in the sizes, intensity, and frequency of those as well. Here's an example locally here on a north-facing slope. You have a cereal stand. Here, nearly pure aspen. The couple of conifers in there are actually junipers. They're not going to take over that stand, I assure you. And so these next one is the one I've been working most in the last few years in the Colorado Plateau region. These vast stands of upland aspen that are not being invaded over time. Several hundred years of no fire evidence. But again, so fire is not a big factor here, but drought and insects and disease-related factors can be somewhat sizable, and then low-intensity gap phase replacement, a very different ecology, as that should be clear by now. Terrain isolated, again, really small, pure stands, three very different situations, and this is admittedly kind of a catch-all bin here. This is a local situation, just a little depression, a little different kind of rooting zone and water retention there than in surrounding alpine vegetation. This is a moraine up in southeast Idaho at just about 50 feet or so in elevation, and it's completely aspen. with pretty much growing out of rock, and then this is an avalanche chute here that will remain in aspen because of very frequent disturbance cycle. And so, as you might guess, a large variation in disturbance types, frequencies, but mostly small sizes, and they can run the gamut of intensity as well. So, and then we have a whole different suite, you might say, of dominant disturbances here in these riparian zones. A pure one, a cereal one, flood, beaver, limited fire with the right intensity and enough conifers in there. But this, there's some resilience built in with this water availability. And so a very different underground system going on there with the adjacent water availability. So I want to get to these confounding factors, and what I mean by that is factors that will limit resilience and have limited resilience. And you'll see a theme right off that they're almost entirely human-induced. So past management practices. This is the Pando clone. Maybe Karen or others might talk about it later, but we have a pure aspen stand in the Colorado Plateau, a stable aspen environment. This is about a 22-year-old clear cut. I would suggest that's probably the wrong practice for management. At this time, it was an experimental area, and they put a fence around and protected it. You'll notice there's still a browse line there, so occasionally animals get into the fenced area. But some of these past management practices put us in non-resilient situations. So we don't have any vertical diversity in this new stand. The whole surrounding area, as you might have heard in other reports, is dying very rapidly with very little regeneration due to some other factors I'll get to in a minute. Domestic and wild herbivores are a big part of that. Depending on how we manage these systems, we put things in a pretty precarious situation. I've been saying this for quite a while. We know this. This is old science, how to make aspen reproduce. There's probably 50 ways in which you could, cut it, burn it, throw dynamite at it, almost anything, and it'll regenerate. The real key here is sort of taking off on what Simon was saying earlier, is what's next? That's the real key, and particularly in this changing environment. So this is a clear cut or clear fell coppice in southern Utah in a cereal aspen stand, and this is also about 20 years ago, and it's no longer a forest. This is right out of Forest Service manual. I finally tracked down to Region 3, which, if you're not familiar, is Arizona and New Mexico. But basically, don't do anything is the message. Do not do any management unless you have a plan for subsequently protecting that in some way in areas of known and documented herbivory. And that's a big issue here. So here's some of our favorite characters here. It can be sheep, elk, deer, and cattle in various combinations. But this is really critical. It's probably where I'm spending most of my time lately. This is regeneration in the Pando clone in a different part that's not fenced. Very tiny, not surviving at all. Incidentally, we put a fence around part of this. Within a month, we have things that are knee-high to waist-high. This is after 10 to 20 years of no seedlings, essentially no seedlings or saplings surviving. So what's going on there? It's pretty clear from this ghost aspen forest in the Book Cliffs. This is a previous aspen forest. Every tree is dead. There's no regeneration. In this case, the culprit is Rocky Mountain elk. And we have a very serious situation there. So from James Peak, more and more totality of management of land cannot involve simply forest management, but a range of considerations in the wildlife realm. But also, if we're going for biodiversity, we need to be considering the impacts on a number of ecosystem components. So, and finally, climate. Others have spoke about this and are more informed about this than me, but this is some previous work I did with a 1,000-year climate reconstruction based on the online information from Cook et al. And this is the current time going back, essentially, the 20th century here. This is for the area right immediately surrounding the Bear River Range here, is the wettest century in the last 1,000 years. And so it's no wonder we would have in our immediate area a proliferation of conifers over that time in cirral systems only. So that affects, as Dominic referred to, disturbance environments quite a bit. And so we have variability that's affected by climate, and we know we have some idea how that might change in the future. I'm going to have to speed up a little here. I'm running down on time. But so this was brought up by others earlier. Do we have anomalous conditions, or can we pick up some valuable lessons from climate and analogs? I wouldn't go as far as Connie Millar has in her work. I would say it'd be a combination of these. There are some very valuable things that can tell us how ecological systems react to climate, although we're likely headed down this path. I'm going to have to skip through this quickly, but basically we need a lot of considerations as we move forward that are specific to these functional types and how they're affected by these human-induced confounding factors that may throw them off. Again, another shot of the Pando clone where there is zero regeneration in there and up to 75% overstory death. So let's a couple of scenarios here quickly. If we think temperature is going up and precipitation down, and we have a cirral system here, montane cirral system, we would expect an increase in fire, which would cause an increase in aspen, sort of what Dominic was saying, but we have a confounding factor here in a decrease in distribution. This is some of the work in sort of the envelope modeling going on where you just have aspen going upslope. And so those things work in opposition to each other. How they interact, probably a little of each, but I wouldn't buy any one of those singly. But really, it's a question of what we do. How do we continue approaching fire suppression as we move forward? Do we build a more resilient system? Same with tree harvest. I would suggest that this fire suppression in many instances has put us in a less resilient position. Sometimes tree harvest has if it's inappropriate for that functional type. Another scenario, same kind of setup. This is in the book Cliffs. This is a very drought-prone aspen forest where drought is going to, if drought is increasing as we move forward, we would expect a decrease in aspen. Again, backing up a little of what Dominic was saying, but the increase in elevation, decrease in distribution. But browsing is a big factor here. Remember, we're in a different type now. So we're in a stable type, and we need those multiple height and age levels in a very complex vertical structure. If we bring everything down to a single overstory structure and then we take away all the babies and teenagers, we're in a very precarious situation. Same with tree harvest, appropriate for that functional type as we move forward to build resilience into the system. So I'm going to quickly lay out my definition of resilience is understanding the function and putting emphasis on process. This is not counter to the idea of tinkering and saving all the parts from Aldo Leopold, but I'm going to say put emphasis on the parts being really processes. So let's see. I just want to sort of throw out the idea of functional types being applied to other types of systems, vegetation systems that are very widespread and probably likely react differently in different places. For example, Doug fir. Is interior Doug fir the same kind of ecosystem as a coastal Doug fir? Likely not. Same with pinyon juniper over a very large area and sagebrush even over a larger area. Are they the same? Others, I always refer to the Ponderosa pine wars from British Columbia to Mexico. Are all those Ponderosa pine systems the same? Frequent fire cycles, park-like? I would put forth the vote of no. With that in mind, I want to thank the folks that have sponsored this work, the BLM, several Forest Service regions, Utah State's Ecology Center, the College of Natural Resources, and of course the Western Aspen Alliance. So I'll take any questions. Questions, so go ahead. Yeah, Allison.
It's not so much a question. I wanted to thank you for really bringing up the herbivory issue. You know, Dominic made it clear that going forward with the confounding factors that are being studied, such as aspen burns and it would come back and it possibly not coming back at all because of the windrow and other factors. And so if you're not studying the herbivory factor, we're really kind of leaving us
I'll take it. So just to repeat, she's saying that we need to emphasize herbivory, and some other speakers are going to talk about that later. But I would agree. I also need to make the point that herbivory is not a problem everywhere. It's about understanding your local system and plugging it into different ecological functional types, and different critters are more important in different places. And all of those critters, I would put forward, are managed to some degree by humans. So all of these things are human, these confounding factors, in my view, are human regulated, manipulated, influenced at least, and they vary quite a bit. So it's not an across-the-board statement about herbivory. Thank you. Yes. Oh, there you are in the dark.
And maybe you can just expound a little bit on this, on what you're seeing and what your thoughts are. As I go out and look, particularly in Utah, as Allison pointed out, a lot of those aspen cones and aspen stems kind of seem to be in, for lack of a better word, kind of marginal sites. They're almost no-facing soils, and places that have a little bit of soil, have a little bit of moisture. Those are the ones small in the scale size. And those appear to be the ones that really take it in the short from the herbivory standpoint. Anytime we try to do something in those scales, everything's ice cream, and it just gets munched in. But it seems as you go up just a little bit higher in elevation, you can do a lot of things in there, and herbivories are not an issue. And you get regeneration that comes back really well, almost regardless of the size of the scale that you're treating or dealing with. And so I guess my question really is, what's the applied, to us as land managers? What do we do with those? Do we sit back and do nothing with those small patches, understanding what they are given current landscape and uses of the land? I mean, what do we really do? I mean, are those aspen stands on the way out because of climate change and we really don't need to do anything with them, or should we be doing something?
So his question, if I can sort of reiterate in brief, is what about those little isolated stands? I think often they're at lower elevation. They may be naturally drier, and if we can take climate change uphill in this instance, they would dry out faster. And I'll step out on a limb and say, are they just throwaway, and should we focus our energy on something a little safer where there's maybe more moisture? A couple of responses. One is some of the work that Dominic and his colleagues have done of saying that some of those stands at middle elevations are a little bit, are more vulnerable than we would think. So that's point number one. And number two, it depends on the local geographical context. If there's a lot of aspen around and you have limited resources, you may have to give up on those. The downside of that is often where there's less aspen cover on a landscape, it's ecologically more important. So you're going to have to weigh those things out. In southwest Wyoming, where we were this summer, the landscape had very far-flung, isolated, tiny stands, and almost to 100% of them covered in a sea of sagebrush, isolated stands. They were completely hammered. I would say their ecological importance is very high in those cases, and so in that context, they need to focus all the energy they can on those because they're going to actually blink out to non-forest types on a very large landscape. So if you have other aspen in the area that's perhaps not as threatened, you as land and wildlife managers will have to weigh those things out. I'm not a great fan of the, sacrifice that one and give it away, but sometimes it's a matter of just what resources are available. That's the best I can answer that, but I can talk to you more later.